Now let us see some more examples. So suppose we are having a YouTube manometer as shown in the figure and it is open to the atmosphere. It means that the same pressure is acting from both the sides and hence the liquid level is same in both the limbs or in both the legs. And it contains a column of length L of a certain liquid. So this is the column of the liquid whose length is L. We have to find out what will be the natural period of oscillations of the liquid column. So suppose you tilt this YouTube manometer and then release, then there will be oscillations and we have to find out the frequency of that particular oscillation. Suppose you displace the liquid in the downward direction like this by tilting the YouTube manometer. Correspondingly, the level will go up in the another limb. So this is the left limb where the liquid level is going down. This is the right limb where the liquid level is going up. So total displaced liquid, suppose this level is X in the downward direction, the same will be in the upward direction also. So X plus X will be the 2X and that is the total liquid that is displaced above the above and below the mean position. So with reference to this mean position that we have shown by this center line, x plus x is 2x, that is the height of the liquid which is displaced. So the frequency of oscillation we have to find out of this particular displaced liquid. So here it will go down, it will go up again, here it will go down in this limb and it will go up in this limb. So it will do some oscillations and we have to find out that particular frequency of that particular oscillation. So suppose it goes up, so inertia force will act in the downward direction. This mx double dot is the inertia force. Capital M is the mass of the entire liquid, whereas the force or weight of the displaced liquid will act in the downward direction. So here we have taken into consideration small m, which is nothing but the weight or mass of the displaced liquid only. So that is mg. So these are the two restoring forces which will act opposite to the direction of the motion if the motion of the displaced liquid is in the upward direction. So important part is this capital M, which is the mass of the entire liquid which we are displacing by tilting this particular U2 manometer. So initially we are tilting this manometer and above and below the mean position the liquid that is displaced is X, which will also provide the restoring force and that is taken care by this particular term, that is F, that is equal to mg. Weight will always act in the vertically downward direction and the weight that we have taken into consideration or force F that we have taken into consideration is that of the displaced liquid only. Now we can find out the mass of the liquid which is displaced. So mass, we know that it is volume into density. Mass density we have to take into consideration. Volume is in meter cube and density is in kg per meter cube. Volume is nothing but area multiplied by length multiplied by density. So area is A, length of the liquid which is displaced above and below the mean position is 2x multiplied by rho. Capital M will be the mass of the entire liquid that has been displaced in the manometer. So similar to this, it will have the relation for capital M also. So A is the area and instead of 2x write down L because L is the total length of the liquid which is present inside the YouTube manometer. So we have calculated the values of small m and capital M. Now force is equal to restoring force which is offered by the displaced liquid is mg that we have seen. Now substitute the value of m that just now we have calculated, that is A multiplied by 2x into rho multiplied by g, that is the gravitational acceleration. So this is our third equation. Now we'll write down the equation of motion. So mx double dot plus f is equal to 0. So This is the inertia force and this is the restoring force. M, we know that it is A multiplied by L multiplied by rho. X double dot is the acceleration. F is A 2x rho g is equal to 0. Now we can take, we have divide throughout by AL rho, so that we'll have only X double dot on this side. So this is X double dot plus A 2x rho g divided by AL rho. So divide throughout by AL rho. And now cancel out this AA and rho from the numerator. So it is X double dot plus 2xg 2x 2g upon L multiplied by X is equal to 0. So just we have rearranged the terms. So this is our equation of motion. And now we can compare this particular equation with the equation of simple harmonic motion. So it is x double dot plus omega square x is equal to 0. So omega square has to be equal to 2g upon L. So we can say that omega will be equal to square root of 2g upon L. Write on the formula for omega that we know from physics. So it is 2 pi f is equal to square root of 2g by L. So f will be equal to 1 upon 2 pi square root of 2g by L in hertz. So this is the frequency of oscillation of the small displaced liquid in U-tube manometer. Now, suppose we are having another example in which a wooden cylinder of diameter d and specific gravity of the cylinder is S cylinder floats vertically in a distilled water. So water level which is shown is that of the distilled water, and this is the wooden cylinder and its diameter is capital D. It is depressed slightly. So this particular wooden cylinder is depressed. It is pressed slightly inside the water and then released so that it will start making some oscillations. And we have to find out what will be the frequency of oscillations of the cylinder if it stays upright all the time. So it is remaining in the upright position, that is the vertical position in this case. So suppose this is the displaced position. So we have put this wooden cylinder, press this wooden cylinder in the downward direction by this much amount. Correct. So it will go inside the water by that much amount. So this is the distance x by which it is pressed inside, and corresponding, this is the corresponding distance by which it will go inside this water, distilled water. So this is now the dotted position is the new position of our cylinder, and then it is released so that it will make some oscillations, and we have to find out what will be the frequency of that oscillation. So whatever is the level x that we have depressed, the same level will be represented over here, or the same level will be over here. So this is our new position of the cylinder. Now the important part, some basic we have to see from our fluid mechanics. So specific gravity or relative density RD will be equal to density of a material divided by density of water. So this is the definition of specific gravity, that is rho divided by rho of water. So rho of any material divided by rho of water, and we know that rho of water, mass density of water is 1000, so it is rho upon 1000. So relation between rho and S is that rho will be always equal to, or S will be equal to rho upon 1000. So rho will be equal to S multiplied by 1000. So, and this is mass density, so it is mass per unit volume, so it is having unit of kg per meter cube. So rho cylinder will be equal to, replace this S by S cylinder, multiply by 1000 as it is. So rho is replaced by rho cylinder, S is replaced by S cylinder. Similarly, if you want to find out rho of liquid, then replace this S by S of liquid multiplied by 1000. So we are now having the expression for both, that is rho cylinder and rho liquid. Now let mass is equal to, so mass of the liquid, small liquid which is displaced because of the pressing of that particular cylinder. So that is equal to volume into density. So as we have done in the earlier example also. So volume is nothing but area into length multiplied by density. So area is A, displaced liquid is X, and density of the liquid is rho liquid. Now this is A X as it is. Now rho liquid is nothing but S liquid multiplied by 1000. That just now we have seen. So we can say that area is pi by 4 d square. That is the area of the cylinder multiplied by X is the displaced liquid, S liquid as it is, and 1000 as it is. So this is the mass of the liquid which is displaced. Now mass of the entire cylinder will be equal to pi by 4 d square into height of the cylinder, and so you can see in place of area, now we are directly written this. So area is pi by 4 d square. Instead of X, it is H now. Instead of S liquid, it is S cylinder, and 1000 as it is. So directly we have come to this particular step, that is volume into density. So this is pi by 4 d square into H S cylinder multiplied by 1000, and mass is in kg. So unit for this both these terms is in kg. Small m and capital M both are having the unit of kg, and that is mentioned here. Now the equation of motion is inertia force plus restoring force is equal to 0. Inertia force will be for entire cylinder, whereas the restoring force will be only for the small mass of the liquid that is displaced. That is, force or weight will always act vertically in the downward direction. So W is equal to mg. So here F is equal to mg. Now mx double dot plus mg is equal to 0, divided throughout by capital M. So x double dot plus mg by m is equal to 0. Now substitute the values of m, small m, and capital M. So it is pi by 4 d square into x is liquid multiplied by 1000 multiplied by g whole divided by pi by 4 d square into H is cylinder into 1000. So this is the value of capital M which we have written in the denominator. So pi by 4 will get cancelled out. D square will get cancelled out. 1000 will also get cancelled out. So we are left with only G S liquid divided by H S cylinder and X. So this is the equation of motion, final form of equation of motion for the cylinder. Now we have to compare this particular equation with the equation of simple harmonic motion as we are doing. So x double dot plus omega square x is equal to 0. So omega square, if you compare these two equations, omega square has to be equal to this term which we have written. So taking square root of both the sides, so omega will be equal to g multiplied by s liquid divided by h multiplied by s cylinder. And omega is nothing but it is 2 pi f. Rest of the terms are as it is. So frequency of oscillation of the cylinder in the upright position is 1 upon 2 pi. Transfer this 2 pi on this side. So it is 1 upon 2 pi square root of g multiplied by s cylinder divided by h multiplied by s, g multiplied by s liquid divided by h multiplied by s cylinder in hertz or cycles per second or oscillations per second. So in this way, we can derive the expressions for frequency of oscillations